you have a factor where a can't be divided out, so you have to factor what adds to 2 and 5 to 10, but also equals the b value, 11. So that's your first step.
Okay. So the major mistake here, and this is like that guy mistake that I was telling you guys about, is that we're trying to cancel individual terms that are right next to pluses and minuses, right? That's kind of the main thing that we want to watch out for, because we don't want to be that guy. So Carlo is suggesting that we start by factoring. Okay, so a lot of you guys did that, but I did see a couple people first start by doing factoring when a is equal to 1, which we know we cannot do. So we're looking to factor the quadratic 2x squared plus 11x plus 5. That is our major rule. Anytime we start any of these questions, if I have multiple terms in the numerator and denominator, I want to factor a common factor. Okay? So, excuse me. We're going to cross-factor this guy, or whichever method you have decided to use to factor a trinomial when a does not equal 1. I posted some videos for you guys a while back. You choose that method. Also, the thing on the bottom here is a difference of squares. So we can also factor that guy. Okay? So many groups, I was a little bit sad to see that so many groups forgot a really important part of their answer. Restrictions. Anytime we have variables in the denominator, before we cancel, it's factor, restrict, and then cancel, okay? Just so we don't forget, okay? And you guys probably saw firsthand today that a lot of your groups, even though there were 3 people in some of the groups, they forgot to restrict, okay? So that's always kind of the in-between step. Before I cancel, I want to restrict. So you should have restricted 5 and -5. I also saw a lot of restrictions of 0. Okay, 0 is actually not a restriction here. Why is 0 not a restriction?
It's next to 1, and then it's also -25.
Yeah, so if I sub in 0 here, in order for me to say, oh, this thing is a restriction, I need to be able to sub it in, and it causes the denominator to equal 0. If I plug in 0 here, I actually get -25. So that's not a restriction. So my restrictions are just positive and -5, and then I can actually cancel out the x plus 5s. So I'm left with 2x plus 1 over x minus 5. Sam, can I go any further than this?
No.
Why not?
Because x is beside 5. Negative.
Right. So I don't want to go ahead and keep canceling here because these x's are right next to pluses and minuses, and we know anytime we go to do that, that is a problem, so we must stop. Okay, so this is actually as far as we were able to go with this question. Okay, I'm telling you right now, I see this all the time, that people start questions like this. So that's why we're doing this, so that we can make sure that we don't do that.
Wait, so you can't cancel with the x's?
In my left-hand thing?
The one that you just did, the end answer.
In the end answer, no, we can't, because again, that's the same problem as what I was doing up here, right? I'm trying to cancel individual terms out when they're being added and subtracted. So again, when I go to cancel something, I need to look next to it and see if there's pluses or minuses next to it.
What would happen if you did that? It would just end up with -5, 2 plus 1.
Yeah, which is not correct. Okay. Yeah. Okay, so watch out for that too. Good? Any questions? Okay. So we're going to do our last lesson today, which is adding and subtracting. Lessons are up on my desk if you happen not to have one. You can come grab.
When's your test?
So our test for this unit, before you all start talking again, just you can be calm, be quiet. Our test for this unit is scheduled for Thursday. Okay, so after today, we actually have 2 in-class days of review. On Wednesday, I have some conversations scheduled. I mentioned those on Friday. I have some conversations scheduled for us, which count for marks. And I'm going to kind of show you guys an example of what that looks like tomorrow. But it's going to be actually something kind of similar to this kind of idea. So the first thing that you guys probably did when you got into your groups is found the mistake, and then talked about how we might correct that, right? So, oh well, she's canceling things that have like individual terms, so right next to pluses and minuses. That's something we definitely don't want to do. So this would be kind of like a conversation that we have where you get a sample question and you have to kind of look through it to see if there's any kind of major mistakes going on and stuff like that, okay? So this is a little taste of kind of like what we'll be doing on Wednesday. But I'll show you a sample of that tomorrow and what exactly that looks like and what I'd be looking for from you. Okay? Okay. All right, so adding and subtracting fractions. So this is different than multiplying and dividing, of course, because it's a different operation. Also, we need to make sure that we follow the correct fraction rules, right? So anytime I am adding fractions, I will always need to make sure that I have a common denominator. That is actually vastly different than what happens when we multiply and divide, because we don't need a common denominator when we're multiplying and dividing fractions. Okay, so that's our major difference here, is that when we're adding and subtracting, we need that common denominator. So I think each side needs the variable that the other side has, and they also have to have a common coefficient. So this side needs to become 6, and it also needs the x that this side has. So I'm going to do whatever I do on the bottom, also to the top. Okay, and then this side already has the 6 part down, but it needs the y that the other side has. So needs a y on top and bottom. Okay, also just a little note, in the back of my mind, I kind of pre-looked at these fractions just to make sure there wasn't anything that could be reduced, just to save me some time. That's what we always want to look for.
So
Carla?
to give them the same value, you go to like, let's say your numerator is 2x, then you multiply that to the bottom?
No, I'm trying to make the denominators the same. So I'm looking at the numbers in front of the denominators, which were 3 and 6. So I think the common number there is 6. So that's why I multiplied this by 2.
Oh,
And then this side had an x, and this side needs it, and this side had a y, and this side needs it.
So it's not actually, it's a cross, essentially.
Yeah, we're not multiplying by the numerators, although I can see why you asked that, because
Yeah.
it actually looks like we're doing that.
Yeah.
Okay, so here we're going to get 4x squared over 6xy plus y squared over 6xy. Okay, and then all we need to do at this point is just move these two fractions together. So remember, we add and subtract the numerators only. We don't add and subtract the denominator. The denominator stays as it is once we have that common denominator. Okay? I also just want to be careful about going in the opposite direction here, because once I've found the common denominator, I don't want to go and reduce what I just did. Right? So I don't want to move back to what I had originally. I want to move toward putting these two fractions together as one. Now, is there anything else that I can do with this particular guy here?
No,
Why not, Luca?
because you can't take anything out. Like you can't lower it.
Yeah. So I would actually just be looking at the two terms in the numerator here to see if they have any common factor. If not, I would need to be able to common factor something from both of those terms to cancel it with the denominator. So I have to leave it like this, but I am missing something. Carlo?
Sorry, I was going to ask,
Sure.
if you have like together like terms, would you do that
Yep.
before you finalize your answer? Like if you had like
Yep.
4x squared plus like 8x squared, you just do
Yep.
Okay.
I'm missing something. Zion?
Restrictions.
Yeah. So Zion, any idea what my restrictions would be here?
X can't be equal to 0 and like.
Good. Yeah. Because if either of these guys are equal to 0, then it causes the whole bottom to be 0 because they're being multiplied. Good. Paige.
What's being multiplied?
The 6, the x, and the y, those are all being multiplied together. So as soon as one of them is 0, it makes the whole thing 0. Good? Okay. So my initial thing that I'm always looking for in these types of questions is, can either of these individual fractions be reduced before I start finding that common denominator? That will save me some work at the end. So is anything able to be reduced before we start? I can't cross cancel here, so I can only cancel in like the individual fractions themselves.
Don't you have to bring a y on the other side?
So before we do that though, we want to look and see, Sebastian?
It's not like an X on the right side.
Yeah, so notice that the numerator and denominator on the right side both have an x. So I think we can take out an x from each of those. And we'd be left with 2x over 5. Okay, if you forget to do this, you will have to common factor at the end to cancel. Okay, so it's always in your best interest to look at those two fractions that you're starting with and see if anything can be reduced at all. Okay, now we can find a common denominator. What would my common denominator be between 6y and 5? 30, and then this side also needs the y that the other side has. So I'm going to multiply the left side by 5 and then the right side by 6y. Oh, 30. Okay, now we're going to put these guys together. Okay, I also would just like to, before we potentially continue this, just make a side note. Even if I've reduced it, like in the very initial first fraction, it still has to be reduced. So see how there's an x and a y in my initial equation in the denominators? I have to restrict both of those. So x cannot be 0 and y can also not be 0 for this question. Okay. In order to express this in simplest form, is there anything more that I can do here? Remembering that factored form is simplest form. Elise? So anything, any variable that was once in a denominator at any time must always be restricted.
Oh, so even if we can cancel that, we just don't have to. Okay.
Yep. Yep. Any further with this guy? Okay, I think there's something common in the top though. An x. So I think we can actually, and this is just good practice to just double check at the end to see if there's any common factors. Even if it can't be canceled, because factored form is simplest form. And just in case maybe I missed something at the beginning, as far as reducing, I just want to double check, because if I can common factor something, then I always want to check if I can maybe reduce it with that denominator. Here we can't, but the rule still stands that factored form is simplest form. So I would like this to be common factored so that it's in fully simplified form here.
So all we did was just common factor the x out.
Yeah, exactly. Just common factor the x out.
What about the y? Can't you like just eliminate the 30 side?
Like these?
Yeah.
Should I do this? Yeah, this term right here is right beside a subtraction, right? Yeah, so we want to be careful about that. Good, Carlo.
So just one thing, when we were up before, so if you wanted to get to like a common multiple, so like 30 between 6 and 5, you
Yep.
have to do whatever you do to the top to the bottom.
Yep.
Okay, so that's why you're doing 5 and then 6 on the top.
Yeah,
Okay.
because when I multiply 5 on top and 5 on the bottom, 5 over 5 is just equal to 1.
Yes.
So I'm not actually changing the fraction, right? But if I only multiply it into the denominator, I'm changing the whole fraction.
Fraction,
Yeah.
Okay.
So whatever I do to the top, do to the bottom. Yep. Cool, okay. Let's try some that are maybe a little bit more challenging. Okay, so I'm gonna write maybe just like a little set of steps to kind of give us an idea of what we wanna do. So the first step, for every single one of these questions, factor and common factor everything that you can, okay? So you could just remember that as a general step for all questions, whether it's subtraction, multiplication, division, any one of those. That's what we always want to do. So let's just do our first step here. I think the only thing that we can really factor is the trinomial in the bottom left here. So I think that's x plus 2, x minus, or x plus 1. And then I always as I did when I was multiplying and dividing, I kind of bracket up those terms there. Okay, now this is kind of where things start to diverge from our multiplication and division questions, okay? So the first thing that I want you guys to be aware of is that when I have a plus or a minus between here, I definitely don't want to do the cross-canceling thing that we do with multiplication, right? I can't cancel anything in this denominator with this numerator or vice versa, okay? I can only cancel in individual fractions only. So if I happen to have maybe something common here that I could reduce, or in this second fraction that I could reduce, I would do that. So that's kind of the second thing that I look for. So can an individual fraction be reduced? Kind of like we did in that second question there, but no cross reducing, okay? Okay, if yes, of course, do so. It will just save you some time. But no cross reducing, okay? That's only for multiplication. Okay, so only in an individual fraction I can cancel a top with a bottom, or in the other individual fraction I can cancel a top with a bottom. Here that's not possible, so we can't actually do it in this example. We're going to restrict, of course. So I'll just do it right underneath our step here. X cannot be -2 and -1. Okay. Third thing, or fourth thing, we're going to go common denominator and merge the fractions. Okay, so these questions are actually quite different from multiplication and division. The only thing that we have to do with multiplication is essentially like factor everything, and then we restrict it, and then we can start to cancel like crazy. Here we want to get these into one individual fraction. So essentially, when I'm working with expressions like this, I just want each side to have the bracket that the other side has. So this side has an x plus 2 and an x plus 1. This side needs that x plus 2. But because this side already needs an x plus 1, there's nothing that I have to do to this first fraction. So really on the second one, I just want this x plus 2 over here.
So we're doing what we did before. You're essentially just multiplying that x plus 2 into that to essentially
Yeah.
get it equal.
In the first two questions you're talking about?
Yes.
Yeah.
Yeah.
Same idea. Yeah. Okay, we're going to merge these guys into one fraction.
Wait, why would you have time to do the second fraction like that?
We're finding a common denominator so that we can put them together. Okay, so common denominator, check, and we've merged it into one, check. Now, this is what I want to caution you guys about. When I have not all multiplication happening on top, when I have like an addition, even though these are being multiplied, I still can't cancel individual terms out of this, okay? So what I really want to make sure I don't do, and this is kind of the trap that some people fall into, see how this x plus 2 has a multiplication next to it? Some people will do this. You cannot, however, do that because this is being added. It would have to be all multiplication on top for you to be able to cancel. Okay, so the idea stands that if I'm adding multiple things on the top or even subtracting, I don't want to cancel out individual parts of those things. So we cannot do this, so be careful about that. What I can potentially do here is if I expand and simplify my numerator, if I can possibly factor that guy, I might be able to get it in fully, like all being multiplied, and then maybe I'll be able to cancel. So my last couple steps here are expand numerator and simplify. Did you have a question back there?
Yeah, I should
So remember, we're not multiplying though, right? So when we add fractions, we add the numerators and we keep the denominator as it is. Okay, just like we did in the first two questions, just keep the denominator. Okay, so we're going to expand and simplify the numerator only. Why is it not necessary for me to expand the denominator?
It's already be simplified.
It's already fully factored, yeah, exactly. Okay, so I'm going to FOIL this guy right here. And because it's being added, I can actually just drop out the brackets once I've done that. Okay, because I'm just like adding whatever I get there. So it's x squared plus x minus 2. That's what it looks like when it's expanded. Okay, that's the expand part. I'm going to gather up some like terms up here. X squared plus 5x minus 2. Okay, and then the last step is kind of like a maybe you can or maybe you can't kind of thing. So once we've expanded and simplified the numerator, can we factor or common factor the numerator? If yes, you're going to do so. If no, you're done. Sorry, I know these steps are going long, but okay. So my last question, can I factor or common factor that numerator? If my answer is no, I'm done. If my answer is yes, I'm going to, of course, do it and then see if you can factor or see if you can cancel anything, okay? Okay, so it's kind of like a decision tree where we say, okay, now can I common factor or factor anything else? Yes, okay, then I'm going to do it, and then I'm going to see if I can maybe cancel something. If it's no, then I'm finished. So the question that we would be asking ourselves here is there anything that multiplies to -2 and adds to 5? I don't think we're going to get anything adding to 5 that also multiplies to -2. So I think our answer here is no. So we're actually finished with this. And our restrictions from above are part of our final answer. So x cannot be -2 and -1. Okay, so sometimes you'll be done at step number 5. Any questions on that one? Carlo?
Sorry, so when we go back up and we added the x plus 2 to our numerators and our denominators, we weren't multiplying those in, sorry, like there.
We are multiplying them in, yeah.
Oh, okay, because when we have x minus 1, x plus 2.
Those are being multiplied, right?
So like x minus 1, x plus 2, so then you get x minus 1, x plus 2 on the top. Then what about the bottom? Because we have...
The bottom is being multiplied because they're right next to one another, but I don't need to expand that because it's already in fully factored form.
Oh, okay, so I was just confused because if we did like x plus 1 and then x plus 2, shouldn't you have 2 x plus 2's on the bottom?
Okay, so that's what Claire was asking. So when I add fractions, I add the numerators and I keep the denominator. So like look back at our maybe simpler ones up here. Do I have two 30y's here or do I just have 30y? Right, so we keep that denominator that we have and we just put the numerators together.
So just, like, actually, okay, you don't actually, okay, that makes
Yeah,
sense.
so we don't have multiples of those, right?
Okay.
Okay, good. Okay, let's try it with this. So first, yeah, Andrew, sorry. Yep. Okay. These ones are a little bit longer than our multiplication and division ones, so we'll do a little break eventually, but we need to do a few more before we get to that point. So factor and common factor everything. I think here we get factors of, what, +8 and -6? And then Okay, focus in here, people. Okay, so I have factored everything. My next step is just to do a quick little check, because this is going to honestly save me. If this is possible for me to maybe reduce in an individual fraction, then I want to do that. Trust me when I say you want to do that. Okay, can I reduce anything in these individual fractions? I don't think so, because I have x minus 9s, and then the denominators don't have x minus 9s. Or in the left numerator, I have an x plus 9. That denominator doesn't have that. So I can't reduce. So we go to the next step, which is to restrict. So off to the side here, I'm just going to restrict quickly. I can't have negative 8, positive 6, and negative 5. Okay, once you've done that at that step, there's going to be no more restrictions introduced to your question. So you're done with the restrictions. Claire?
Next, you have to bring up the x plus 8 and the
Yep.
x plus 5.
Yep, so each side needs the bracket that the other side does not have. So this side needs the x plus 8. And this side needs the x plus 5. Good. So we're finding a common denominator, and we're going to merge these into one fraction. Oh. Okay, now I only have one of these denominators, right? You keep the denominator and then put the numerators together. So it doesn't matter the order that you put these in. Okay, it's like 7 times 2 times 4, or 4 times 7 times 2, same thing. Oh, sorry, not 4 there. I was saying 4, so I wrote 4. 8. Okay, I'm just going to write you a nice little note right here. No canceling just yet, okay? Sometimes people like to go cancel happy. Okay, there's no canceling yet at this step. Okay, why is there no canceling at this step? Yes, and the problem with this numerator right here is that I have a subtraction in between all of this. In order for me to cancel, I'd have to have all multiplication on top. Okay, Carlo, did you have a question?
Yes, so I understand
Yep.
the reason you weren't writing them in like square root of brackets, it doesn't matter how many of them you have on the denominator, as long as you're just writing that they're there. It's like even if you had like x plus 5 and then x plus 5 twice, you just wrote x plus 5 once on the denominator.
So it's not that it doesn't matter how many I have per se, it's just that when we add fractions, we've already found that common denominator, and we're just putting them together as one fraction. So I'm not actually adding the denominators, I'm just saying I have this over this and also this over this, and I can write them together.
Okay.
Right? Does that make sense?
Yes.
Okay, cool. So someone told us that we need to FOIL first, which is correct. So we're going to take a second and expand and simplify the numerator. I want you to be very careful with this second guy here. This is a little bit different than the question we just did, because the question we just did, we were adding. This one, we're subtracting. So actually, everything that I get from this second expansion, the x minus 9 and x plus 8, the negative applies to all of that. So I'm actually going to just maintain those brackets there in that second fraction. I can drop the ones, or the second expression there. I can drop the ones in the first, though. So we're going to get x squared plus 14x plus 45 minus, and then I'm maintaining the bracket here. Okay, I trust you guys know how to FOIL at this point, so I'm just going to do it quickly. Okay, this is the one major difference between addition and subtraction. Okay, it's literally exactly the same except for this part right here, because I actually have to put this negative into each term in that second foiling that I did there. Okay, so I think, never mind, I'll just write the step. I wasn't going to, but save myself some space. But so all the signs in that second guy are going to change because I'm putting in a negative there. Okay, we're going to simplify that numerator, so gather any like terms. The x squareds cancel each other. I've got 15x and 45 and 72. What does that give us? 117. Okay, my last step always is to see if I can factor or common factor that numerator. Now the numerator is not a trinomial, so I know I can't use trinomial factoring. The only thing that I could potentially do here is common factor. So is there any common factor between 15 and 117? So the things I might check, of course 5 doesn't go into 117, but I might check 3. So does 3 go into 117? Yes, Elise says yes. So I think I can take a 3 out from both of these terms here. I'll be left with 5x, and Elise, how many times did 3 go into 117? 39. Okay, so we're left with 39 there. And thankfully we are done because I'm at the end of my space. And I'm just going to put that less x plus 8 on the bottom there, but you guys know it goes in line with these. Okay, now because this 5x plus 39 isn't the same as any of these brackets in the denominator, I can't cancel. If it happened to be, then I would actually take that extra step and cancel out. But this is actually going to be my final answer here, along with my restrictions. Any questions on that one? Okay.
So when you're subtracting, you have the second bracket. You're keeping that and just multiplying the negative into them, basically. Like where we had
Yeah.
x squared minus
Yeah,
x squared.
exactly. You got it. Okay, we'll take 2 minutes and then we'll finish up those last 2 questions, okay? So 2-minute break. If you want to check your phone, you can. So just a little thought. Maybe we want to write ourselves a little note on here, just saying that this step right here is a major difference between addition and subtraction, okay? So okay, so maybe we make ourselves a little cloud on our note. And we just say that that one little step right there, factoring in that negative to the second term, is our major difference with addition and subtraction, okay? So maybe that's, if you have a highlighter on you, maybe you can even just like highlight that little step there where you're bringing in that negative, okay? That's really the only difference. Cool, okay. And I fixed this up, so this is what the final answer should look like. Okay. I just I had it crammed in the side there, so I just wrote it. Okay, good. Okay, let's try another one. Claire, can you grab that back door there? Thank you. Okay, factor and common factor everything. I'm going to use my space up here. Try to use it wisely. Okay, I think that this step of kind of bracketing up some of these terms is also especially important because if I multiply something in, I want to think of these things as groupings. Over here, I think we're factoring into plus 4 and plus 2. Multiplies to 8, adds to 6. Okay. Step number 2 is just to double check our fractions, make sure that we can't reduce individual fractions. So I don't think that there's anything that can be reduced in either one of these fractions. So I think we can go ahead and just restrict. So maybe I'll just write the restrictions up here for now. X cannot equal -2 and -4. Box those guys up. Okay, and then we're going to go to the find the common denominator step. So we need an x plus 4 on the left. I think that's all that we need. And we're going to put them together. Okay, again, this is the step that we want to make sure there's no canceling happening at. I can't cancel these x plus 4s because of the plus in between in the top. So I need to expand and simplify the numerator. Okay, so I'm going to FOIL this. And I think we can just, like, this is really like us just putting in a positive 1 into that second part. So we can just drop the brackets on that guy. And then all over x plus 4, x plus 2. Simplify like terms. Okay, and then my final check here is just to double check if anything else can potentially be factored. So we actually have a resulting trinomial on top here. Are there any two things that multiply to 2 and add to 3? Zion? 2 and 1. Okay, so I can actually, I'm going to go actually over here. I can actually simplify this to x plus 1, x plus 2. Okay, and you should notice something now. Paige, question?
Can you FOIL the top?
Right, at this last step here?
Yeah.
If we FOIL it, then we're going to be back here.
Oh.
So what was the point of us factoring?
Simplifying.
So what can we simplify anything else here?
Yes, we can take the x2 and the x plus 2.
Ah, okay, so we can actually simplify this even more now, right? Now that we've factored in and simplified. So I'm actually left with x plus 1 over x plus 4. Okay, and then our restrictions from above were x could not be -4 and -2. Okay, so this is as simplified as we can get for that guy. Now, the kind of cool thing that I haven't shown you guys yet is what this actually looks like graphically, because you'll notice that, yes, -2 is a restriction, but we don't see it in the final answer. So I wonder if maybe the restriction of -4, because it is in the final answer here, maybe produces something different graphically than the one that gets canceled out along the way. I know you all are wondering, so thanks for asking. I will show you. Okay, so one thing that we should be able to do is we should be able to graph the original function and graph the final function and get the same graph, because those things are equal. One is just the simplified version of the other one. Okay, so on one hand, I have what we just found, which is y equals x plus 1 over x plus 4. Okay, and you may notice this looks kind of similar to some of those functions that we did in our domain and range questions, right? So where do you notice the vertical asymptote of this function is?
What?
Vertical asymptote.
What's that mean?
Oh.
Okay, you guys remember?
-4.
It's at -4. That's interesting. How does that relate back to our restrictions?
That's
One of our restrictions is -4.
One of our restrictions was -4. I know the numbers are hard to see, but it's right here, and this is -4. Okay, now, no, these two rooms are connected because sometimes we open them, but, okay. Okay, so this is the fully simplified equation though. If I were to enter the original equation, you guys are gonna see basically almost the exact same function, but it's gonna have one tiny, tiny difference. So I'm just gonna enter it in quickly here. We have x plus 9 over x squared plus 2x minus 48. Sorry, wrong one. I was doing the one before. X plus 2, and I have to change this to minus 2. That looks better. And then I have x plus 10 over. So if you have a graphing calculator, does anybody have a graphing calculator in here?
What?
Anyone have a graphing calculator? So you could actually check your answer here. See how these graphs are overlapping?
Yes.
Okay, that's because the equation that I just simplified is the same graph as what I should get as my resulting thing, right? What I started with should be what I finished with. The main difference here, and I want everybody looking at this because this is going to be part of your conversations on Wednesday, okay? There's one big difference, and that is that I still have that vertical asymptote at -4, but because I've actually taken steps to simplify this guy, what happens at -2? Well, at -2, you guys will see if I hover right over that. Was it 2 or -2? Oh, it was -2. Okay. So at -2, what do you see? What does that say? Undefined, because that's a restriction in my initial function. So although it gets canceled out in my original function, I actually, because I started with this, and I had a -2 restriction to start with, it doesn't produce one of those vertical asymptotes because this guy still is in my final function. That produces a vertical asymptote, but if it gets canceled out along the way somewhere, it actually just produces like a kind of like one of those hollow undefined points that we talked about in our domain and range unit. So this guy right here, this guy's a vertical asymptote. Okay, it's kind of like one of those lines that our graph naturally avoids. It curves around it. Okay, whereas this guy here, this is just an undefined point on the graph. Okay, so you'll kind of see it as like a little hollow point on your graph.
So you should always have two of those restrictions then? Just
No, not necessarily. You might have one or the other, or you could technically have neither.
okay. There would always be one of these.
Or you could have two vertical asymptotes.
Oh, okay.
That's possible. Maureen? Yep. Okay, last question. Okay, and then maybe we'll discuss what the restrictions mean on this guy too. Okay, so factor and common factor everything. First step always. I'm seeing a difference of squares on the top left here, which will factor into 5x plus 6, 5x minus 6. Okay, I'm going to leave that one for a second. That's factoring when a does not equal 1. This is another difference of squares, x plus 4, x minus 4. This one's factoring when a equals 1, so I think we get 3 and 1 for the numbers here. Okay, this guy we need to, however you've decided to factor trinomials like this. So I showed you this method, the breakdown method, and we need to try to get the middle term to equal -1. So I think we're going to do 1 and -6. That should work for us because then we get 5x minus 6x, and that gives us -1x. So those are our brackets. Okay.
Cross them out if they're in the same fraction.
Okay, so that's the second step, right? If we can cancel an individual fraction, in an individual fraction, we want to make sure we do that. Now, most of the time, this step will be irrelevant, but in this case, you're actually going to get something insane if you don't factor first, or if you don't cancel first. So you're going to get like what we call a cubic, which is like even higher than a quadratic, and you guys don't know how to factor those things. Karen?
Would you restrict before you cancel it out?
Yes, so we're going to restrict, of course. Maybe I should have put that as the second step rather than this. But we can't have -1, we can't have -3. And does anyone remember how to do ones like 5x minus 6? What's the restriction for that? Zion?
Take the number to the right and put it over the number to the left and change the sign.
Okay, so what would we get here?
6 over 5.
6 over 5. Okay, take the number on the right, put it over the number on the left, and switch the sign. So 6 over 5 and make it positive. Okay, now, because I can actually cancel in this left fraction over here, I'm actually just going to cancel these guys out. This is a lifesaver right here. This makes our life so much easier. We definitely want to make sure we do this if we can in these addition and subtraction questions. Okay, so now I just want to find a common denominator, right? So I think this left side just needs that x plus 3 that the other side has. So we will do x plus 3 on bottom and top. And because we canceled the 5x minus 6, we don't need to put it on the right-hand side, right? That's canceled out. And I'm going to just put these together since they're all in one fraction now. They have a common denominator. Okay, we're going to expand and simplify the numerator here. So FOIL. What do we get here? 6x and 15 is 21. Okay, just a little note that I'm keeping those brackets. Sorry, I can't scroll up anymore because this is the end of the lesson. So you'll have to look around, people, if you can't see at the bottom here. Okay, notice again that because this is a subtraction question, I'm maintaining those brackets around that second half because I know that that negative has to go into both of these terms here. Okay, that's that main step. We don't want to forget about that, so I'm going to put some stars there. Okay, and then we're going to get, well, I guess I'll just rewrite it. Isabella?
Where'd you get 21 from?
I was just foiling this, so I got x times 6 plus 3 times 5x, so 15 and 6. Right, because we're doing first outside, inside, last. I'm just simplifying as I go. Yeah. So normally you'd get like 2 x terms. I'm just adding them together in my head. Yeah. Okay, and I'm just going to finish this on my screen here so that you guys can see. Gather like terms. So I think we're left with 4x squared, 21x still, and 34. Okay. Factor or common factor? That is the question. Can I? So I would be looking for what two numbers? Something that multiplies to 4 times 34, which is what? 136, and adds to 21. So this is the question. Can I factor this? I think that was right. Let me just see. 4 times 34. So I'm looking for things that could potentially multiply to 136 and add to 21. Is this going to happen? I actually don't know. So we need to figure out. So I'm thinking if I do this, 17 and 2 multiply to 34. Does that add to 21? No, it doesn't.
No.
Any other things that multiply to 34? 34,
You got 9 and 6.
9 and 6, that's 30, that's 54. I don't think this is factorable. Anyone? Kira, did you find anything? No? I don't think there's anything. Unless we do like 2x and 2x maybe. Let's just double check here. And then like 17 and 2, no. No, okay, so I think we can safely say that this is not factorable and that this is a final answer. And of course, our restrictions are part of that final answer as well. So make sure you box. And 6 over 5. Okay, remember, anything that was once in the denominator needs to be reduced or restricted.
Why is 6 over 5?
Because of this guy right here. I just circled it. Okay, because of this 5x plus 6, or 5x minus 6, sorry.
Can I go to the washroom?
No, we're just gonna wait like 2 seconds. So final restrictions, can somebody tell me which of these are vertical asymptotes and which of these are undefined points? Isabella?
-1, -3 are the vertical asymptotes.
Right, how do you know?
Because they're in the final.
Right. So restrictions that you can see in the final solutions, those are vertical asymptotes. Whereas the 6 over 5, it got canceled along the way. That's just an undefined point. Okay, and this goes for all of our questions, the multiplication and division ones as well. These are causing the same types of things to be happening graphically.
There's always a vertical asymptote and it's reflected in the actual expression.
Yep,
Okay, and then like that's why 6 over 5 would be undefined.
right, because you don't see it in the final answer. Yep.
Okay.
Good. Okay, so we're going to do some practice today. I'm going to stop this. Oops, sorry.